Greetings and welcome to STEM Smart Academy. Welcome all. Thank you for joining this live session. Before we start, share this link to your other friends. Subscribe to our channel so that you don't miss any update. Our consultation number is at the top here. That is 0741 30 43 11. You can reach out for consultation and even for tuition programs. So today we are going to discuss the Kenyan National Math Gurus Examination Council Mathematics Paper 1, and we are going to have focus in Paper 2, sorry, Section 2 of this paper, because we finished discussing Section 1. In case you didn't find time to go through this Section 1, it is uploaded in our YouTube channel. Go through it because it's a wonderful question paper. I'm going straight to Section 2 of this paper. Subscribe, like, and share the videos. Thank you to those who are joining live. Thank you. I appreciate. Thank you. So remember, math needs daily practice. That's why I do upload these contents on daily basis to make sure that my subscribers are up to date. That's why I request all of you to make sure you've subscribed for your own betterness. So let's look at question number 17. A train of length to 40 meters leaves station P heading towards station Q at an average speed of 54 kilometers per hour. At the same time, a motorbike leaves station Q towards station P at an average speed of 72 kilometers per hour. The distance between the two stations is 150 kilometers. If the motorbike started overtaking the train at point M, determine at 1 the time taken by the motorbike to reach point M. So here we are having two stations. Let's illustrate them diagrammatically so that we understand this concept better. I've got station P and station Q. That is as per the question paper. We are being told that a train of length to 40 meters leaves station P towards Q. So P to Q, here we have a train. The speed of this train is 54 kilometers per hour. At the same time, a motorbike leaves, we have a motorbike which leaves Q towards P. We have a motorbike. It leaves Q towards P at a speed of 72 kilometers per hour. The distance between the two stations is 150 kilometers. If the motorbike started overtaking the train at point M, at us overtaking, okay, the train at point M, so maybe they began overtaking at this point here, can call this point M. If the motorbike started overtaking the train at point M, determine the time taken by the motorbike to reach point M. So when you have such a question, what are some of the things that you need to bear in mind? One, let's compute what is called the relative speed. And the relative speed, because the two vehicles are approaching each other, we are going now to add. So this is 54 plus 72. This becomes 126 kilometers per hour. So after we've gotten that, let's now get the time. Remember, time is given by distance over speed. Our distance here is 150 kilometers. That is the distance between the two towns, divided by the speed, which is now 126. This is now going to give you when you take 150 divided by 126, that is like saying one whole number 4/21 hours. One whole number 4/21 hours. That is the time taken by the motorbike to reach town M. But Roman 2, the time taken from point M, so the time taken from point M for the motorbike to overtake the train completely. So because now they want that time, remember that time is equal to distance over the speed. Distance over the speed. I now want you learners to know this. Remember, when you look at the question, the train has a length of 240 meters. For it to be overtaken completely, meaning a distance of 240 meters has to be covered. So that 240 meters, let's convert it to kilometers by dividing it by 1,000. So when you take 240 divided by 1,000, that will be 0.24 over the relative speed in which it was moving, which is 126. And this is going to give you, when you work on it, this is going to give us 1/5/25 hours. The time taken from point M. Remember, it's just from point M after they began meeting. So from point M to overtake completely, the only distance to be covered is 240. And remember, when you have here 240 meters, this is equivalent to saying 0.24 kilometers as our distance. That's why I used it here over the relative speed. You can see how this paper is. Just imagine doing like that, you have your 3 marks. No more stories here in mathematics. Let's look at Roman 2. The distance from P to M in kilometers. So to get the distance, remember distance is given by speed times time. From P to M, let's look at it, P to M. P to M, it is the train that was moving from P to M, and it was moving at a speed of 54 kilometers per hour. So it will be 54 times this time will be the time taken to meet, which we found here is one whole number 4/21, which we can say to be 25/21. So the time here will be 25/21. When you multiply in your calculators 54 times 25/21, you are going to get 64 whole number 2/7. 64 whole number 2/7 kilometers. As simple as that, ladies and gentlemen. Part B, after overtaking each other, the train reduces its speed to 45 kilometers per hour for the remaining journey to Q. If both the motorbike and the train arrive at their destination at the same time, determine the distance from M to Q. The distance from M to Q. Now you can see, I want you to be very keen. Let's look at here. Remember that the motorbike was moving at a speed of 72 kilometers per hour. And it was, and it took from M, they want the distance from M to Q. M to Q, when you look at M to Q, remember, from our diagram, M is the meeting point. So M to Q is the distance covered by the motorbike before it overtook the train. So I'll take the distance will be the speed, which is 72 kilometers per hour, times the time taken to overtake, which is one whole number 4/21. So this will just be like saying, they want now the distance. I'll say distance is given by speed multiplied by time. The speed is 72 kilometers per hour times time. One whole number 4/21 is just like saying 25/21. Not really that way. There's something here that you need to know. There is something that you need to know. Remember, dear learner, I want to bring this to your attention keenly. So follow this keenly because I'm saying it's involving. Or let me use a different version here. There's something I want to instill to you before we use this. Let's have again our the very sketch here. I told you that with math, once you sketch, you are half done. PQ, this is a train, this is a motorbike. We have a point M here. So what we can say here, because they are saying that after overtaking each other, the train speed now reduces to 45. Now the speed of the train becomes 45 kilometers per hour, meaning that the bike will retain its original speed of 72. The bike will retain its original speed of 72 kilometers per hour. If both the motorbike and the train arrive at their destination at the same time, so they have overtaken each other here, meaning that the time taken by the train to move from M to Q should be equal to the time taken by the bike to move from M to P. So I can say maybe let time taken by the motorbike from maybe M to P be equals to K. So if this distance here becomes K kilometers, remember the total distance from P to Q was 150, then M to Q here will become now 150 minus K. So if I take the time taken by the motorbike now has to cover K kilometers, so it will be K over the speed of the motorbike, which is 72. This should be equivalent to at the time taken by the motorist, sorry, the train here will be covering a distance of 150 minus K over the new speed of the motorist of the train. Remember, the new speed of the train is now 45, so over 45. Then when you're here, you cross multiply. This will become 45K is equals to 72 into 150 minus K. So this will be 45K being equal to, and here you need now to be keen, 72 times 150. That is going to be 10,800. We have here 10,800 minus 72K. Then you collect the like terms. When you collect the like terms, 72 plus 45. 72 plus 45, that becomes 117K is equivalent to 10,800. When you divide through by 117, it means the value of K is going to be 92 whole number 4 over 13 kilometers. But now because they want the distance M to Q, it will be now 150 minus 92 whole number 4 over 13. And when you compute that, you're going to get the distance as 57.9 over 13 kilometers. 57 whole number 9 over 13 kilometers. That's how you are supposed to respond to such type of a question. Allow I proceed now to question number 18. That is a question on geometry. Now, points P, Q, and R are 4 locations on a map drawn to a scale such that Q is equal to 6 centimeters from P on a bearing of 60 degrees, and R is 9 kilometers from P on a bearing of 150 degrees. S lies due east of R and due south of Q. Using a scale of 1 centimeter representing 1.5 kilometers, part A, construct an accurate diagram to show the positions of P, Q, R, and S. So let's, before we construct it, we are going to start reading it from the top as we are constructing one by one. They are saying that Q is 6 kilometers from P on a bearing of 60 degrees. It means I have P, I have town P here. I want you to follow this keenly because questions on bearing tend to come often in exams. This is my compass. That's the north. This is my point P. They are saying Q is on a bearing of 60 degrees. So when they say 60 degrees, remember we measure from the North Pole in the clockwise direction, like that. So once again, I want you to be very keen. So this is our Q, such that Q is 6 kilometers. So this is 6 kilometers. And when you measure this angle, it is 60 degrees from the North Pole up to here, 60 degrees, but that is 6 kilometers. R is 9 kilometers. R is 9 kilometers from P on a bearing of 150 degrees. Bearing of 150 degrees. So the bearing of 150 degrees from the north again, bearing of 150 degrees, takes it this way. It takes it this way. Just a moment. Yes, like that. Such that from the North Pole up to here, it is 150 degrees. But remember, we have said that R is 9 kilometers. So this distance here is 9 kilometers. 9 kilometers. So here we can locate our compass because it's very important to have your compasses located like that. So this is R. Then we're being told that S lies due east of R. Due east of R we have S, and due south of Q S lies due east of R and due south of Q. Sorry, let me correct something here. I had not measured. Remember, I'm approximating my measurements. So let me assume that this is my R. This is 9 kilometers. Then they are saying S lies due east of R. Due east of R. From R you go to the right hand side, that is the eastern side, and due south of Q. From Q, south of Q from Q is that way. That way. So this point here, this is our S. Then construct, I've done my construction that way. As simple as that. Simple as that. I have all my 4 points. Now, what is the next question saying? Measure the distance between Q and S in kilometers. Q and S in kilometers. So you just measure this distance from Q to S. Then you record it here. That one is simple. find the bearing of S from P. S from P, first what you do, you join S to P. Let's join S to P this way. S to P. After that joining, because they want the bearing of S from P, meaning from P here, this angle here is the angle you are going to get, then you can be able to fill that. Part D, a commutator, a communication tower, T, is located such that Q is equidistant from QR. I think say that Q is equidistant from Q and R, and the T lies on the side of QR opposite P. Let's look at that. A communication tower T is located such that Q is equidistant from Q and R. Q and R. Equidistance from Q and R. I think so. Equidistance from Q and R. First you join Q to R. Allow I join Q to R. Then being equidistant from a point equidistant from these 2 points is simply a point you bisect this line anywhere that way. But again they are saying such that T lies on the side of QR. T lies on the side of QR. T lies on the side of QR, opposite of P. Opposite of P. Locate T and determine the distance QT. So that is your T. I think this question had its own complexity. More so, let me see. Yes. Let's have a look at question number 19 now. The figure below shows a model of a metal funnel consisting of a frustum of a cone attached to a cylindrical neck close at the bottom. The top radius of the frustum is 7 centimeters, while the cylindrical neck has a radius of 3.5 centimeters and a height of 8 centimeters. Calculate the curved surface area of the frustum. The curved surface area of the frustum. First of all, to get the curved surface area of the frustum, remember the vertical height is from here to here it's 8. This is 3.5. So I want to get the slant height L, the small L. So to get that slant height, which is going to be the square root of 3.5 squared plus 8 squared, which is going to give you 8.7 centimeters. That is the slant height of the smaller part of the cone that is immersed in a cylinder. Then after getting it that way, we are going to use similarity, whereby I'll say L over 8.7 should be equal to the bigger radius there is 7, so that will be 7 over 3.5. This is going to give me the total slant height of the original cone. You cross multiply. Therefore, my L will be given by 7 times 8.7 divided by 3.5. So, in that context, our slant height, when you have 7 times 8.7 divided by 3.5, you get 17.4. centimeters, as the total slant height from here coming down to here is 17.4. So to get the curved surface area of the frustum, it's normally pi RL minus pi RL. Curved surface area is pi RL minus pi RL. So our pi here is 22/7 times the bigger radius 7 times the bigger slant height, which is 17.4, minus 22/7 times the radius 3.5 times the slant height of 8.7. So this will give you, when you take 22/7 multiplied by 7 multiplied by 17.4, that is 382.8 minus then 22/7 times 3.5 times 8.7, that is 95.7. Then when you subtract, you're going to get 287.1. 287.1 square centimeters as the answer for that part. Part B, the total surface area outside the model. The total surface area outside the model. So, because we have already found the curved surface area of the frustum, we also now need to consider the bottom are the circular parts. First, I have to consider a lot. I want to get the curved surface area of the cylinder. Curved surface area of the cylinder, which is normally given by pi dh. So 22/7 times the diameter. If the radius is 3.5, then the diameter is going to be 7 times the height of 8. So that gives you, when you take 22/7 times 7 times 8, that gives you 176. So that is 176 square centimeters. After that, I need also to calculate the bottom circular part, which is pi r squared. So the bottom part, because it's circular, it is going to be 22/7 times r squared, which is 3.5 squared. This is going to give you 22/7 times 3.5 squared. That gives you 38.5. That 8.5 square centimeters. Then also we have the circular top here, this part. Remember, this is the top. This is what I'm referring to, the top. This is the part I'm referring to, the bottom, that you need to know. So the top has a radius of 7. So for the top, because it has a radius of 7, it will be 22/7 times 7 squared, which is 154 square centimeters. So the total surface area, you take the top, which is 154, plus the bottom, which is that 8.5, plus the curved surface area of the cylinder, which is 176, then plus the curved surface area of the frustum, which we found to be 287.1. Then you sum this, so 154 plus that 8.5 plus 176 plus 287.1, 655.6. This gives you 655.6 square centimeters. Part C, if the metal sheet costs this one per meter for 20 shillings per square meter, find the total cost for making the model. So total cost, you take the total, let me check on this. These are centimeters. I'm now going to take very simple. I'll take the total area, which is 655.6 over, I'm going to divide this by 10,000 because this one is in square meters. Then I multiply this by 420 to get my amount. So when you have that, let me do it using my calculator. I'm getting the total cost as 27.54. 27.54 shillings. 27.54 shillings. That's how you could have responded to that question. Let's have a look at question number 20. That question number 20. We are now going to question number 20. Ladies and gentlemen, subscribe, like, and share these videos with your other friends. Drop a comment in the chat section telling us where you are following us live. Very, very important. Dear learner, keep subscribing. I'm so much happy hosting you in my YouTube channel. That a farmer fenced a rectangular piece of land using 120 square meter or 120 meter of fence. He used all the wire, leaving no gap. The length of the land is 5 meters more than twice its width. Form an equation representing the above information. First of all, what I want you to understand, this is a rectangular piece of land. They are saying the length of the land is 5 meters more than this. So if this is K, if this is K, then it means that the width will be the length of the land is 5 meters more than twice its width. More than twice its width. So if this is K, what will be the measurement for the width? Twice the width will be or rather, maybe let me start by saying let the width be K. That will be simple. Let my width be K. If my width is K, then the length is 5 meters more than twice the width. So this one will be 2K plus 5. That gives you the length. Exactly. That is now simpler. Form an equation representing the above information. An equation here, because fencing, this is like perimeter. Remember, perimeter is given by 2 into L plus width. So the perimeter, which is now 120, is equal to 2 into the length is 2K plus 5 plus the width, which is K. So this is going to give you 120 is going to be equal to 2K plus K, that is 3K times 2. That's going to give you 6K plus 10. So we have 6K plus 10 is equal to 120 as the equation. 6K plus 10 is equal to 120. So we can finally express our answer this way. that maybe we can say 6k plus 10 and equate it to 120. This is what is called an equation because of the equal sign. Let's proceed to question number B. Solve the equation to find the dimensions of the land. So the equation, remember the equation we have here is 6k plus 10 is equals to 120. What you do here, you collect like terms. So this will become 6k will be equal to 120 minus 10. So 6k will be equals to 110. Then the value of k will be obtained by taking 110 divided by 6. So using your calculator, dear learner, when you take 110, you divide by 6, you get the value of k is 18 and a third. 18 and a third meters as the value of k. After you have that as the value of k, after you have that as the value of k, what are you going to do next? They want the dimensions of the land. That means the width of the land is k, which is 18 and a third meters. Then the length of this land is 2k, so that will be 2 into, remember, 18 and a third can be written as 55 over 3, 2 into 55 over 3 plus 5. So that is like saying 110 over 3 plus 5. Then we are now going to have our length here finally as, let's have that done. So that is 41 and 2/3, 41 2 over 3 meters. So these are the dimensions. The width is 18 and a third, the length is 41 and 2/3. Part C, find the total surface area of the land. When you are told to find the total surface area of the land, this is just the area. So remember that area is given by length multiplied by the width. The length is 41 2 over 3 multiplied by the width, which is 18 and a third. This is by 18 and a third. So this is going to give you, when you do that multiplication, you're going to put 763 8 over 9 square meters as the area of that land. Part D of the question paper. The farmer increases both dimensions by 2 meters, leaving the shape rectangular. Determine the percentage increase in area. First of all, let's get the new dimensions. So I can get the new length. Remember the old length was, from our calculation, it was 41 2 over 3. So this is now 41 2 over 3 plus 2, meaning it is 43 and 2/3 meters. And the new width, initially it was 18 and a third. It's also getting increased by 2 meters. This makes it to be 20 and a third meters. Let's compute now the new area. Our new area is going to be now 43 2 over 3 being multiplied by 20 and a third. So let's do this multiplication. Let's do the multiplication, ladies and gentlemen. I'm doing my multiplication. This is giving me 887 whole number 8/9 square meters. Because I want to get the percentage increase, first of all I have to compute what is called the increase. Let me compute the increase, which is given by 887 8/9 minus the original area was 763 8/9. So when you compute that, let me work on it. So this gives you 124. There is an area increase of 124 square meter. So now to compute what is called percentage increase, you take the increase over the original value times 100%. Our increase here is 124 over the original value, which is 763 whole number 8/9. Then what you get, to multiply by 100%. And when you compute that, this is going to give us, when you do this computation, let me do the computation. I'm doing the computation, learners. Let me do the computation. Make sure to use your calculator for higher degree of accuracy. So this is like saying 16 whole number 64 over 275%, or you can give it as a fraction, as a decimal, in form of maybe 16.23%. So that is how you calculate the increase of such a question. We are proceeding well. Let's go to question number 21. The table below shows the time in seconds taken by 60 athletes to complete a shuttle run. Complete the table by inserting the following additional columns: the midpoint, x, and the fx. So first of all, let's get the midpoint, and I'm going to add that column here, the column for the midpoint. I'm adding it here. Remember, to get the midpoint, it's very simple. All you have to do, so this is x, which is our midpoint. You take 20 plus 24 divided by 2, that becomes 22. 25 plus 29 divided by 2, that is 27. 30 plus 34 divided by 2, that is 32. 35 plus 39, then you divide by 2 to give you 37. 40 plus 44 divided by 2 to give you 42. That is the column for x, so that one is done. Then fx. Fx means f times x. So I'm going to take 6 times 22, that is 132. 14 times 27, that is 378. 18 times 32, 576. 12 times 37, 444. 10 times 42, that is 420. Just imagine doing like that. You've gotten your 3 marks. Oh my God. Part B, estimate the mean time. So before this, I need to get here the summation of fx. And to get the summation of fx, I'm simply going to populate all of this. So I take 132 plus 378 plus 576 plus 444 plus 420. That is 1950. 1950. Then the summation of frequency here is 60. So when they talk about mean, which is x bar, is given by summation of fx over summation of f. Our summation of fx here is 1950 divided by 60. So when you divide that by 60, you're going to get 32.5 as the mean time, 32.5. Then estimate the median time. Estimate the median time. We need now to estimate the median time. So when you are estimating the median, first what you do, you get the median, what we call the median position. Let's obtain what is called the median position. And because median is the middle value, you take 60, you divide by 2. This means that the median is in the 30th position. Then you go to your CF column, which we don't have, but we can populate. Allow I populate here a column called the cumulative frequency column, CF. So 6, 20, 38, I've said 6, 6 plus 14, 20, 14. Okay, let me add on this other side because even learners will get confused when I'll add here. Let me just add to the far end to make things simpler, the way most of the learners are used to. Because here in STEM Smart Academy, we are here to simplify these concepts, not to complicate them once again. So CF column here. The first value of CF should be equivalent to the first value of F, which is 6. 6 plus 14, you get 20. 20 plus 18, you get 38. 38 plus 12, you get 50. 50 plus 10, you get 60. Then after that, now look at the CF column. Where does 30 lie? 30 lies in this row. So this becomes your median class. That row, this is where the median lies. Now, we now apply the formula for calculating median. We all know that it is median is calculated by taking L plus N over 2 minus CF over F times the class interval I. So our lower class limit here in this circled class will be 29.5. This is now 29.5 plus N over 2, that will be 30, minus the cumulative frequency above the median class. The CF value above is 20 over the frequency of that median class. The frequency of that class is 18 times the class interval I. The class interval 30 to 34. The class interval there is 5. That way. So with that, this is like saying now 29.5 plus, we compute this again. You take 30 minus 20, that is 10, divided by 18, then times 5. So that's like saying 25 over 9. So plus 25 over 9. When you do this addition, ladies and gentlemen, you're going to get the median here is 32 whole number, 5 over 18. Or if you love leaving it as a decimal, it is 32.278, something like that. Part B, state the model class. The model class is the class with the highest frequency. You look at the frequency column. where is the highest frequency? The highest frequency is 18. So which class is corresponding to 18? 30 to 34. So the model class here becomes 30 to 34. Remember, when you choose the model class, consider the class with the highest frequency. Let's look at question number 22, ladies and gentlemen. Keep subscribing, liking, and sharing our videos. If you are interested for online tuitions, you can reach out via the number 07 41 30 43 11. You can call or WhatsApp that number, then our team will be able to respond to you. Find the inverse of matrix A, 3, 5, 2, 4. Before you get the inverse, we have to get what is called the determinant, which is the product of elements in the main diagonal, that is 3 times 4, minus the product of elements in the minor diagonal, that is 2 times 5. So 3 times 4 is 12, minus 2 times 5 is 10. So your determinant here is 2. Now to get the inverse, now, to get the A inverse, you take 1 over the determinant, which is now 2. Then you multiply it by the elements in the main diagonal interchange. 4 goes there, 3 comes down. Then you negate the elements in the minor diagonal, negative 2, negative 5. So when you deal with that, this is like saying 2, negative 2.5, negative 1, 1.5. So this is the inverse of A. You are done with the 2 marks. You can see how simple math is. Part B, 2 types of tickets are sold from a school concert: VIP tickets and regular tickets. School A bought 3 VIP tickets and 2 regular tickets at a cost of 1,100 shillings, while School B bought 5 VIP tickets and 4 regular tickets at a cost of 1,900 shillings. By taking the cost of VIP to be X and the cost of a regular ticket to be Y shillings, write 2 expressions to represent the above equation. I see like there is a term that's wrongly used here. It should not be expressions, but rather equations. In mathematics, the term expression and equation have 2 different meanings. So we should write 2 equations to represent the above information. So that will be 3x. The first equation will be 3x plus 2y should be equivalent to 1,100 shillings. The next one will be 5x plus 4y should be equal to 1,900 shillings. So those 2 that I've written there are what we call equations. Then, by use of matrix method, find the value of x and y. So first of all, I have to represent this one as a matrix equation. These are linear equations. Matrix equations in this manner would have been 3, 5, 2, 4, xy being equal to 1,100 and 1,900. What I've written here, that's what's called a matrix equation. So we are going to pre-multiply the inverse of the matrix to both sides. Remember, I've already found my inverse matrix is 2, negative 2.5. So I have here 2, negative 2.5. Then negative 1, 1.5. Negative 1, 1.5. I pre-multiply on the left, that is 3, 5, 2, 4. xy should be equal to, again to the right, 2, negative 2.5, negative 1, 1.5 times 1,100, 1,900. We have a rule that says that when you multiply the inverse of the matrix times the matrix itself, you get what we do call an identity matrix. If it's a 2 by 2 matrix, it's a 1 0 0 1. So xy should be equal to, remember how to multiply matrices, ladies and gentlemen. It should be row times column, row times column. So let me do 2 times 1100 plus negative 1 times 1900. That gives you 300. Then we have negative 2.5 multiplied by 1100 plus 1.5 being multiplied by 1900. That is 100. Then also, when you multiply the identity matrix but by another matrix, you just get the matrix itself. So this one will become xy is equal to 300, 100. This means the value of x is equivalent to 300. The value of y is equal to 100. That's what it means. We've answered that part. Now we are going to look at part C. Let's look at part C. Find the cost of buying. Sorry for that. Find the cost of buying 2 VIP tickets and 4 regular tickets if their prices were reduced by 5%. So if you reduce the cost by 5%, remember the cost of a VIP ticket was 300. So if you reduce it by 5%, meaning the new cost will be 95 over 100 times the original cost, which is 300. But now how many VIP tickets were bought? 2. So you multiply that by 2 plus regular tickets were 4. And the cost of the regular ticket reduced by 5%, meaning the new cost is 95% of the original, which is 100. So this is going now to give you, let's do it together, 95 over 100 being multiplied by 300, then times 2. This is 570 plus, that is like saying just 4 times 95, which is 380. And when you add this, you are going to get the cost is 950 shillings. So that's how you respond to such a question. Let's look at question number 23. The figure below shows a triangular field ABC with AC is equals to 60 meters and 40 meters and height 40 meters, sorry. A rectangular strip BCDE of perimeter 80 meters is attached to it such that BC is X and CD is Y. Write an expression of Y in terms of X. Because the perimeter of BCDE is 80, what I know is that perimeter is given by 2 into length plus width. The perimeter, which is 80, is equal to 2. The length here is X plus the width here, which is Y. So this will be 80 is equivalent to 2X plus 2Y. So write an expression of Y in terms of X, meaning I need to make Y the subject of the formula. So this means 2Y is equal to 80 minus 2X. And I have to divide both sides by 2. So Y will be given by 80 over 2 minus 2X over 2. So the correct expression here of Y in terms of X will be Y is equal to 40 minus X. Y is equal to 40 minus X as the answer. Roman 2, write a simplified expression of X. Write a simplified expression in X for the total area of the land ABEDC. So the first thing we are going to do, here, because we can get the area first of ABC. Let me get area of ABC. Area of triangle ABC. Because it's a triangle, it's a half times base times height. So this will be a half multiplied by the base of 60 by the height of 40. So this is going to give you 120 square meters as the area of that triangle. After getting that as the area, we also now need to get the area of rectangle BCDE. Let's also get the area. Let's get the area of BCDE, which is length times width. Therefore, that is going to be x times y, which is xy, Then after that, write a simplified expression for the total area. Now, when we are here, okay, I'm just trying to see this. Remember, sorry, this is when you take a half times 60 times 40, it will give you 1,200. I had omitted my 0 there. Then the area of BCD is length times width, which is x times y. But remember this, we had said our y can be equal to 40 minus x. So this can be written as x into 40 minus x. So the area, that area now becomes 40x minus x squared. Now to get the total area, you take the area of the rectangle, which is 1,000, sorry, area of the triangle, which is 1,200, plus the area of the rectangle, which is now 40x minus x squared. You now realize what we've written here is now the area in terms of x. Maybe I can just rewrite it as a quadratic such that it is now negative x squared plus 40x plus 1,200. That is the expression. Determine the value of x and makes the area of the land maximum. To determine the value of x that makes the area of the land maximum, what are you supposed to do here, ladies and gentlemen? So now to get the value of x that makes the total area of the land maximum, when you differentiate area with respect to x, you should be getting 0. When you differentiate for, let me say maybe for area maximum, then dA over dx should be equal to 0. That is a rule. So let's differentiate this. When you are differentiating, remember you drop the power down, then you raise the power by 1 to get the new power. So this will become negative 2x plus 40 is equivalent to 0. So in that context, it means that 2x is equals to 40. Therefore, the value of x is equal to 20. What was the units? Meters. Yes, x is 20 meters. The value of x is 20 meters. But Roman 2, determine the maximum possible area. So now to get the maximum possible area, we are going to fit it back here. Remember, area is given by negative x squared plus 40x plus 1200. So this is going to be now negative 20 squared plus 40 into 20 plus 1200. Remember, it is negative x squared. So when you have negative x squared, ladies and gentlemen, the value of x, remember, is 20. So when you work this out further, this is like saying negative 400 plus 800 plus 1200. And this is like saying 1600 square meters as the area, 1600 square meters as the area for that question. Let's look at question number 24, which is the last question. In the figure below, PQ is one of the sides of a quadrilateral PQRS drawn to scale such that PR is equals to 5 centimeters, angle RPQ is equals to 60 degrees, and angle PQR is equals to 70 degrees, and line PQ is parallel to RS. On the same figure, using a ruler and a pair of compasses only, part 1 complete the quadrilateral PQRS. So we've been told that PR is 5 centimeters. The angle at P is 60 degrees. So let's construct 60 degrees. And I'm going to guide on how to construct 60 degrees. So I'll take my pair of compass and I'm going to stand at P. I'm going to stand at P with my pair of compass. There. I'm going to stand here at P. After standing at P, I'm going to make an arc that way. Then, without adjusting my compass radius, transfer my compass to this point. Then make an arc. Then after that, I can remove my compass. And now, this line here is 60 degrees. That's how you construct the 60 degrees that's required. That is now 60 degrees. After constructing 60 degrees, PQR is 70. You know, with 70, you cannot construct. So, that one, you have to measure. So, let's measure 70 degrees. I'm going to take my protractor. Seems it's too small. Let me increase its size a bit. And I'm going now to measure 70 degrees. 70 degrees. It is 70 degrees is somewhere there. So I want to make 70 degrees. I want to construct 70 degrees. This one I've measured. So 70 degrees is that way. I'll stand from Q here. Remember, 70 you cannot construct. The only option you have is to measure. So that is 70 degrees. Then after that, we are again being told, let me just remove this one. Sorry. Remember, mine might not be that accurate because I'm just following PR should be 5. PR. So the distance from P to R should be 5. So 5 I can measure using 5 centimeters. Where is my compass? It has disappeared. Oh my God. At times it happens. But if it has disappeared, I can still get it. Let me get my compass. Okay. Then I have to ensure it is now 5 centimeters. That way. So I'll stand at P. Here, don't worry about its level of accuracy. It's because I'm enlarging and reducing once again. So 5 centimeters there. So what you need to know, because they say that that distance should be, PQ should be parallel to PS, I have to get another point that is 5 centimeters. I can stand here, and once I stand here, let me just let me make, maybe from here I can drop a perpendicular bisector from this point, so I can stand here at this arc, can stand here at this arc. I want to drop a perpendicular bisector to line PQ, so I extend. This time I want to use blue ink. I'm using blue ink. So you need to be very, very keen. That way, and bring it here, one of our arcs again. After bringing it there, need to rotate this, but let me now reduce this reading. Then what happens here, make an arc, transfer the same compass to this side here, rotate and make an arc that way. Then now you drop a line from the top here, this way, passing through that point. That way, that is the perpendicular bisector. Then you measure that distance. So what happens is, again, we are going to construct a perpendicular bisector at this point anywhere here. Maybe even I can opt, let me construct it here. And to distinguish, I'm going to use a green ink, a black. Let me use a green, can also do. Let me use a green ink. Now, after that, I'm going to make an arc. I'm going to make an arc here, and also to the right hand side, I'm going to make an arc that way. Then transfer my compass to this arc, rotate it a little bit, extend more than half. After extending, what happens? I make an arc. I make an arc here. I take my compass to the other arc I had made previously, the green arc on the left hand side here. I rotate again my compass, and I make an arc. After that, I'm now going to join a line from here, going through those points, and after that I'll now have to draw a straight line from here, cutting that way. Yes, cutting that way. Then I can now label this point. Remember that I can now do my labeling. This is S. Sorry. This is S, and this is R. I'm done with that. I'm done with the 4 marks. Drop a perpendicular from R to meet PQ at T. I already dropped, so this point is T. That point is T. That's already done. So the 2 marks are already gone. So I'm left with 4. With P as the center and radius of 5. P as the center and the radius of 5. Draw an arc cutting PQ at U and passing through R. Cut PQ at U, and passing through R with a radius of 5. That means, let me adjust my compass reading to 5 centimeters first, then radius of 5. Okay, I now take my compass to P, that way. This time I'm doing it with a black pen. I want to do it with a black pen. Okay, I rotate. So it's going to be this way. It's cutting but through R that way, such that after that, what are they saying? After that, they are saying passing through R. I'm done with that drawing. Then you are now being told, calculate the area of quadrilateral PQRS that lies outside the arc in Roman 3. The area of the quadrilateral that lies outside the arc, that is simple. To do that computation, we are now going to say, we are going to have a half. Let me use a half into a plus a half times 8 plus 3.9. Remember, maybe I was not giving you guys the measurements here. My RS, I forgot, my RS is 3.9 centimeters. My RT is 4.4 centimeters. So when I take 8 plus 3.9, what am I meaning? 8 plus 3.9, then times we are doing this calculation well, and it is my hope that you are all understanding. Remember, I'm doing the last part of the question. I'm doing the last part of this wonderful question paper. I'm doing the last part. So when you are here, then after this, you times 4.4. 4.4. So what you get here now minus the angle there, we had it as 60 over 360 times 22 over 7 times r squared, which is now 5 squared in this case. So this one here, a half into this and this is more like a trapezium. I have AB plus H. Remember that quadrilateral is a trapezium, AB plus H, then minus that. So this gives you an area of 13.08 square centimeters as the answer. And that marks the end of this paper. Subscribe, like, and share our revision with your other friends. Keep subscribing and sharing these videos to your other friends. Tell them that STEM Smart Academy is bringing them content live. Thank you for watching. See you in our next session. Goodbye.